This is the office hour for Oregon State. This is call number 6, and the next lesson is lesson 6, soil mapping and analysis, due next Monday, October 6th at 9 a.m. Pacific. We are just coming back after our break, so it'd be nice to see everyone. Okay, and you guys are halfway to the finish line, so give yourselves a pat on the back. And we got Karen here. I'm going to unmute you. Unmute. There. Good morning, Karen.
Good morning. Yeah, good evening. It's
my volume's
evening
off.
Here. Sorry?
I can't hear you because my volume's off. I unmuted you, but I can hear you now. We're good.
Oh, okay. All
Yeah.
right.
Yeah.
So here I am, as promised.
Hi. Yes. I just realized, I had a really nice, quiet day yesterday, and I was like, I feel like I should be doing more students' assignments to mark, but I'm still on my break, so I'm going to keep my boundaries about marking on my break. And I totally forgot to send out the reminder for the office hour.
That's all right. There was somebody named Raquel or something. I don't even know who she is.
Oh, Rachel Donnelly?
Asking about, yeah. So she was asking about the meeting on the WhatsApp group. Yeah. Life happens, hey? So I'm supposed to go do my soil tests, and I went away, and then when I came back, I found out that my clients have gone away. They're in the UK, and they only come back tomorrow. So there's going to be a mad scramble on Wednesday for me to go up and do my soil, take my soil samples.
Okay.
And but I've got it organized. But our soils are quite clayey, so I may have to take some photos after due date to supplement a proper. Yeah.
I see her message here.
Yeah.
Okay, maybe I'll open that. Yeah, Raquel. That must be Rachel Donnelly, I'm guessing, because I don't have a student that I recall. So
you had a good. Are you in British Columbia or are you in Oregon now?
No. Now we're in Northern California.
Okay.
Yeah, so I did spend a little over a month this summer at my mom's in British Columbia. And then the idea was that we were trying to move back up there. But we had some issues with the border. And so we're back down in Northern California for at least till next summer. I kind of anticipate we might end up staying longer, which isn't really what I wanted, but we'll see how that goes.
Okay.
Yeah. So we're back in Northern California, which is really nice. I mean, it's such a great area to be in. It's if you have to be stuck somewhere, it's really not bad, but there was not. It was kind of hard because I was pretty set up to like see family and be able to be there again. So anyway, here we are.
Have the Canadians become more? I know when my son went to work in Canada, he needed a visa, I think, even though he went in as an American citizen, not as a South African. He needed a work visa. Is that correct?
Yeah. That's always been the case between the two countries, that you would need a visa to work, even to volunteer. Actually, like I actually got into trouble at the border once. I didn't realize I would have needed a visa just to volunteer for a couple of weeks.
Wow.
Yeah, they didn't like that very much. So, yeah. Good morning, Vincent. Oh, he's muted. Oh, there we go.
Yes, several mutes.
How are you doing?
Good.
Okay.
Vincent.
Hello.
All right. So I'll I'll just go through my little tutorial here, I guess, if that's all right. Vincent, do you have any questions off at the outset?
No, I don't think so. I think the only question I had was actually related more to lesson 6. I think so for my test sites that I gathered samples from, I picked out one that was like native soil that was unamended, one that was in our pollinator terraces, and then one from our vegetable garden, so that I could kind of see what the organic matter was and everything from each location. Is that okay, or was I supposed to pick 3 of the same type of soil?
No,
Okay.
that's perfect. Yeah, no, pick 3 different ones. That's great.
Okay.
Because then you get an idea of what the range looks like, especially if you've got a site that's been amended. You have a better idea. You almost kind of give yourself a timeline if you're comparing something that you know there hasn't really been any work done, and then comparing something that you have a pretty good idea of what's been added to it or how long that's been worked or amended to. Then you can get an idea of like, well, it's going to take me about 5 or 10 years to get this native soil to where you want it based on what your goals are. So no, that's great. Yeah. Karen, have you gone through this assignment yet?
Lesson 7? No.
No, we're on lesson 6.
Okay. Yeah, no, yeah. I haven't finished. I'm kind of, I was supposed to be catching up on all my reading and whatever, and I haven't caught up on everything. So I've read the textbook, and I've read Bill Mollison's section on soils. But I've mapped out what I need to do in the field. So when I go out to my site, I can, I know exactly what I need to do, and I'll be preparing my tools, my infiltration pipe and that sort of thing. But I haven't done I've spent a lot of time understanding the paleogeography of where our soils came from, and perhaps that probably was a waste of time. It was really interesting. And I ran into a fossilized dinosaur on my break, and I decided that he could tell the story of our soils here. So that was kind of fun. But I've had to learn a lot of terminology and, trying to understand what things mean. For example, what is the hydric content of soils, and how do you get from the general classifications of soils in the region to what you actually have in your back garden or your client's garden or whatever, and what do they call those? And so I have spent a lot of time with that background learning.
Sure.
So hopefully the next 4 days I'll be able to do the assignment as I should.
Sure. Okay.
According to the instruction. Reflective points.
Yeah, I mean, and soil. I mean, I would say soil ecology, but just any science of soils is so complex in that, way back when it really started off as like understanding what the parent materials are. Yeah. Which is where a lot of those, the paleo, paleontological analyses came from, and then understanding some of the chemical drivers, and then the hydrology and the biology of all of that. Like it's really, really multiple. Yeah,
I doubt that I'll get to the point where I really understand the cations and the anions and the whatever. And I was quite shocked today watching a video on soil infiltration, and to realize that clay soils don't release that moisture. The guy who was doing the demonstration was talking about what do you call it? Permanent wilting. Write it down somewhere. Yeah. And I, my soils stay moist because I've got a lot of clay in them here at the house. But I didn't realize that those plants may not. I could never understand why plants were wilting when I had moist soils, and it's obviously the vegetables that don't have the ability to pull any more moisture out of the soil. And so anyway, that was very interesting, and I just it's just not stuff I've known before.
Yeah, and some of it's kind of counterintuitive like that. The other thing with clay soils is that they can hold a lot of nutrients, but they also tend to bind it very tightly because they've got usually high like cation anionic exchange. So the clay soils are really interesting. I mean, I'm quite sure there's people that have their entire careers built around just the studies of clay soil dynamics. So.
And the way they write about it is so technical. It's just beyond my pay grade or something.
Right. Have you encountered any of Matt Power's books on soil?
No.
So
I went in.
He's another California guy. He put out a textbook a few years ago, and it's not a even on thrift books at $75. I'll send you his Kajabi. I'll put this Kajabi site in the chat here.
Okay, thank you. I went to the library and got our standard texts. I think it's Martin Fay for South African soils.
Okay.
But I haven't looked at any international level of authors. And then I also got a book on soil science from UNISA, which is our online university here.
Oh, sure.
And that's actually been quite helpful. But I don't think I can reference a UNISA field laboratory book. But anyway, it's been helpful in helping me understand. But I think Martin Fay, Charles van der Merwe and Martin Fay, I don't know where, I probably left his book in the lounge, are two classic soil books for South African soils.
Okay. Now I've got the link kind of a little bit further down here in my agenda. Soil map and test. So South Africa, there's actually there's a soil and terrain database, SOTER for South Africa.
There is?
There is, yeah.
Because I looked at all the databases that were given to us as resources, and when I got to South Africa, it just said there was no data. And then looking on South African sites, our Department of Water and Sanitation publishes, or they post reports that have been done, like surveys for hydrological surveys for boreholes or different things. But there are none, absolutely none of our area here that my site is involved with. So I'd love to know what site you're talking about.
Okay, I'm going to do a little share here, and I'll drop the.
Because I'm just really, I couldn't find. I've been looking for research articles, and I've just sort of I've been doing a literature review, which doesn't put me in a very good mood.
No, and that's the thing with these, these sites that get put together, is they're like multiple literature reviews, all kind of. So, yeah. So there's Southern Africa.
Yeah, that is what does SOTER stand for?
Soil and Terrain Database for Southern Africa. Oh, that's SOTER South Africa. The Soil and Terrain Database.
Okay, I think
where the SOTER come. It may be. Sometimes it's because they're.
Oh, this is the ISRIC site. I went to it. Okay, maybe I didn't do it properly, but that's the one that I followed the links until eventually I got to South Africa, and it just said, sorry, there's no data. But let me try again.
Are you serious? Oh, I hate that. I hate that when they're like, hey, look, we've got this thing. Oh, we don't actually. So there's the report.
Well, it's not. I mean, if the country doesn't do it, the more I look at it, the more literature I read. So we have a soils department at the university where I am here. And fortunately, our soils department has done a lot of research. And so I've been able to draw on some of those, research articles and stuff. But yeah, it's not nice and tidy like the American information.
Mm-hmm. Yeah, it's unfortunate there's not a USGS soil survey for the entire globe, because it is really handy.
Yeah, that is
Yeah,
nice.
even the Canadian one falls pretty short. So,
Okay.
yeah.
Anyway, it's a
Okay.
learning curve, and I've enjoyed it. So.
Yeah. Well, the nice thing about this assignment is it is arguably one of the shortest assignments in the course. So it's kind of a nice way to ease back in. Now, from what I got from my emails, it looked like you guys got the material for lesson 7 already last Monday.
Yeah, Molson in the discussion, the course discussion, I think they've dropped the lesson 7 materials. Yeah.
Yeah, I saw that. I was like, oh, that seems a week out of sync. But I mean, it doesn't hurt to have the material ahead of time, but we should really just be on lesson 6. So unless I'm a week or two behind, but I've in the early days, I did miss a few. It was really hard for me to tell from the way they laid things out where the break was exactly. So I've gotten really careful about how I like making sure that I've got the dates right. So anyway. But yeah, if you've already got,
I think you're right.
Yeah, I'm okay. All right. Okay, so just a little check-in on this template. Grades are distributed across the soil mapping, 4 points, soil testing, 5 points, which is strange because there's 3 soil tests, but it's 5 points. So soil analysis is 4, and then SWOT analysis is 1 point, so the total is 14. Vince, this is where this kind of references what you were talking about. You'll be taking 3 different soil samples and doing the same analyses on each, but I want you to find 3 different spots on your site. And they're all contained in one assignment. So there's just assignment 13, unlike the others where there's usually 2. And then, like I said, this is one of the shortest assignments in the course, kind of a nice way to ease back in, but it does require more hands-on work than most of the other modules. Most of you, Karen, unfortunately, this won't be you, but you will be able to use the USGS Soil Web Survey. So we'll just do a quick little share. That's going to look like. It's going to look like this one. Oh, maybe stop sharing here just a second. Oh, okay. USGS got closed, so I'm going to close. Anyway, if you haven't been to the USGS Soil Web Soil Survey, you can find it pretty quickly here. Just go Web Soil Survey. I'm going to share that screen. Okay. So if you have not been to the Web Soil Survey yet, you're going to go to hit this big green button. This is your Web Soil Survey, so it does only cover the US. Okay, so what you want to do is create an AOI. You can create an AOI from your shapefile. What that means is that you can upload a zipped shape or SHP file. If you're not sure how to do that, if you have a KMZ or a KML file, like for Google Earth of your property boundary, you can just search free KML or KMZ to shape conversion, and you'll find all sorts of different services. If you're not sure, you can't do it, send it to me, and I've got an online service that I can run them through really quickly in just a few minutes. And then you convert it to that zipped file, and then you can upload it, and it'll automatically give you a property boundary. So yeah, so you can set your AOI. Oh, there you go. So set your AOI there, or you can also just draw. Let me see. I'm going to show. I'll go into California. So if you want to go.
I don't know if it's just my side, but all I see is where the green button says Start WSS.
Oh, really? Okay, yeah, no, that's because it's not sharing on that side yet. Okay, thank you. New share. I always forget when you follow a link to a new There, this one. Okay, so this is what your web soil survey screen is going to look like. So there should be, oh, here we go, by address, quick navigation. Okay, so I'm going to go to where I'm living right now, actually. Now you can see, now you can all see where I live. And I was just about typed in a client's address and I was like, oh, let's not do that. That would be a little, okay, so we're right down here. So I'm going to zoom in here. Zoom in here. Okay, so this is the neighboring house. We're actually in this house right here. So I don't have a property boundary for this property, so I can just do set an AOI. I'm going to select the irregular polygon because a rectangle wouldn't quite fit it properly. So basically, the property we're on runs something like, let's just say it runs something like that. Now, that's just the property. So what I'd like to do, oh, self-intersection, intersecting, that's interesting. Okay. So generally I would go a little bit beyond the actual boundaries so I can see. Yeah. Okay. Oh, I want to do.
You have to double click maybe.
When I was playing with it, I think I had to like click on the corner that I was drawing or something.
Yeah, I did that the first time and it told me I was self-intersecting. So there's my AOI now. And then now you can go to the soil map and then this, and that'll give you the type. So there's just those two types here. So if you click on each of these soil types, you get all that information.
That is so cool.
And then more, yeah, and then more.
Oh my word, you guys.
Close your eyes. So yeah, there's yeah, I don't know what you'll be able to bring up, Karen. Now some of this can get a little bit overwhelming if you can get some of the basics like what the profile looks like, any like distance to bedrock, any kind of drainage, that's going to be fine. Just fill out what you can on the template slide, and that's the best you can do. But I mean, if you're in touch with your university soil group, then they might be able to get you a little more detail there. And then you can
I've asked. They don't have anything. But I'm going to check with Sadara later on.
Okay.
See if they've got something.
There we go. Oops, soil map may not be valid at this scale. Okay. So anyway, so you can play around with that. Get all your data for your site based on that. Sometimes the navigation gets I find a little bit frustrating. Like it's not an automatic zoom in and zoom out. You have to click back and forth between your magnifying glasses, but okay. All right, so there, I'm going to stop the share, but there's your web soil survey. If you're in the US that you can go ahead and use, which most of my students in this group are. Okay, the good news, bad news if you've already done all this part of your assignment. Good news if you haven't is that new soil data is going to be available on Wednesday, October 1st. So just give it 2 days if you haven't done it yet. If you have, it's probably not going to make any enormous changes. I haven't actually seen them do an update, so I'm really curious to see what it's going to look like. After the call, I'm going to grab a few snapshots of like this site and some of my client sites. And just do a comparison to see what's changed from one day, like with that update. Like I said, you can upload an AOI as a zipped shapefile, and AOI is an area of interest if you're not familiar. If you don't know how to, or you can't figure out how to convert a KML or a KMZ to a shapefile, go ahead and email it to me, and I can do that to you, and I'll send it back to you this week. There's the South Africa link. Erin, sounds like it's not going to be that useful to you. Okay, and then the soil testing locations. I'm going to do share. Okay, so soil testing locations. Let's go back here. Most students find that the grayscale version of their base map is the most useful to locate where your soil samples. So it just shows up nicer, rather than the overhead view, and it's clearer, or rather than the color aerial map, and it's clearer than if you just used your linear base map. So I generally recommend using the grayscale. Pick 3 sites you want fairly different conditions. So full sun, full shade, any past livestock areas, past gardening areas. If you've got a site that was, this is especially true for urban, suburban sites, that was leveled and compacted for construction, your soil profile is probably going to look very different, and it's going to be very difficult to get a sample in because that was compacted. And often there's like gravel, or like sometimes it's even like DG, or like there's some sort of material that they've compacted in there to create a solid building surface. So be prepared for either like very hard digging, or for your soil samples to look very different from what the soil survey shows, or some of both. And then just fill out your information, the table, the information bar like you're used to doing, address, area, coordinates, name, date. Make sure your scale and your compass rows are up to date or accurate to the map that you've used in the base map. And then just give me some description, some images of where each soil testing site is going to be, why you chose that, like a little bit of history if you know it, what it looks like currently. Okay. And then you're going to do the same thing 3 times for each. So once for each of those sites. I want you to choose 3 photos here. So one is your soil texture by feel. So that'll be either like your ribbon. Just get a picture of like your ribbon test, your soil ball test. So just a picture of soil in your hand. Your image of a percolation test. So that'll probably be your hole filled with water. And then when you're recording your rate, remember you want to record a depth and a time. So whether that's inches per minute, which is pretty common, centimeters per second, depending how fast things are going down. And you may have to do this a couple of times to see, if it's going down really, really fast, you might want to do it once or twice to get, to get an accurate reading on there, maybe take an average of a few of them. So some of you on very sandy soils, you'll find that you'll put water in and it'll go in, it'll be percolating through as fast as you can fill the hole. So you'll just need to adjust your timing and your rate to reflect that. And then a picture of the hole with your ruler showing the soil profile before you filled it with water to do your percolation test. So you want a picture of what it looks like dry when you're starting out. You can put in an image of your jar test here on the right, and then a site photo of where your soil testing site is for that one. This is pretty much all just like follow the instructions, but I'm trying to highlight things that sometimes students skip because these can be a little bit visually, maybe not cluttered isn't the right word, but it's a visually full. These are visually full slides, so just making sure that you don't skip over anything. Don't forget when you're doing your jar test to include like a drop of dish detergent, because it'll make the adhesions between particles break up. And so your settling is going to happen faster and you're going to get a clearer, more readable separation of particles. And that can take up to like 24 hours. So really give it time to settle out completely. You may still find that you've got some cloudiness in the water, there's stuff that's just in solution. It's not going to settle out. That's fine. It especially happens in clay samples. And then sometimes you'll have some really light organic material that floats to the top and just stays there, and that's also fine. So there's quite a bit of variation in here, but you're looking for those clear striations that you can see in the particulate. So watch the videos. You can also find other videos on jar tests on YouTube and get an idea for how much they vary, like what the different jar test culture are looking like. So just fill out all those little details there, and then use these two. There's an orange dot and a red dot. So the red dot is going to be your jar trial, and your orange dot is going to be your results of your ribbon or your field test. So just copy those dots and then put them onto this little graph wherever you've made those decisions for your soils. Now, keep in mind that those may differ from what your soil survey results look like. So wherever you are, if there's government data or there's, whatever, if there's like regional data or like some other test that's been done in the past, it may differ from what you're finding now, and that's fine. There's an opportunity later in the assignment to explain any differences that you see between your own test and what you would expected to see based on data. Okay, so you're going to have 1, 2, 3 of those. Is there a question? No. Okay.
Yes, I have a question.
Go ahead, Karen. Yep.
Sorry, the pictures that you're asking for seem to suggest that we're going to be digging a hole for a soil profile, but the instructions were to use a tube on the top of the soil which you pound in, and then you measure, you work out your volume and you measure an inch at a time. So are you actually expecting us to dig a soil profile, or are we using just a infiltration rate test?
No, there is actually a digging a soil hole.
Oh, okay. Sorry, I missed that. Okay, I'll go back to the instructions.
Okay. Are you referring to the instructions on the assignment, soil testing?
Yes.
Okay, so jar test. Okay, so soil profile image, take a photo of the rule in your percolation test hole. Percolation test. Can you send me? Oh, okay. If you were on a site where you're not able to dig a hole, there's another method for measuring the percolation rate, which is pounding the tube in.
Oh, okay. Sorry, I thought that was the preferred method.
Okay.
That's fine. We can dig holes. We can just dig holes.
All right. If you can dig a hole, dig a hole. And if you can't, then that's an alternative method. Okay, good. I'm glad you asked that, actually, because I had forgotten that there was that the alternative to not being able to dig a hole, because sometimes I do get students that are like, this is concrete. Okay. All right. And it doesn't have to be a super deep, like usually 6, if you can get 6 inches or 10 inches down, that's great, but enough that you can see the upper layers of your soil profile.
Sure.
Okay. All right. So sharing that. Okay. And then the soil analysis resources and soil building slides. This is where you get to get creative. Whatever your sources of nitrogen-rich greens are going to be. So if that could be grass clippings, livestock manures, whether from your own site or from neighbors, kitchen waste. You can get restaurant food waste, especially for anybody in California. If you want more details on that, I've got some good resources for you for getting kitchen waste from commercial kitchens. So anything like that, any of your rich kind of moisture stuff that you're going to put in as your green material into your compost, and then your carbon rich browns, or some people call them their crunchies, can be leaf litter, dry leaf litter, wood chips, sawdusts, if you can get like sawdust from a lumber mill, that's a good source. Even cardboard will work here. So really get ideas of it, like as many different sources as you can get onto your site here. This is kind of an interesting place to put it, but how do your soil samples compare with the narrative descriptions of the soils on the soil maps? So this spot here kind of comes after all of those actual soil analysis. This is where you're going to put down if your data differs, or if the data differs from what you found based on your ground tests. Based on that information, any of the limiting factors for your soil type. So that might be if there's like a clay pan, a lot of sand, so you've got really fast percolation, a lot of clay, so you've got very slow percolation, a lot of nutrient binding, which Karen and I were just talking about in terms of clay soils. They can bind up a lot of nutrients, and also and if they can seem moist, but they're actually holding a lot of water, it's hard for plants to pull it out of there. So anything like that that comes up from your research can go in here. And then any other resources that can be used for building soil, that might be a source of like vermicompost worms, compost teas that you can get a hold of or that you're going to make. Rock dust is another one, bone meal, fish meal, stuff like that. Those are all good resources to list out there. You can add more rows, you can delete rows off of here, go ahead and amend these so that you can use up that space and make it work for you. Pictures help, pictures are always good. Okay, and then this is going to be your goals and your ideas for actually doing all that soil building work. I'd like to see at least 2 different types of composting methods on your site. So, for instance, on our site in Southern California, we had a vermicompost bin, which was also a human manure composting system. We had a banana circle. We had chicken composting. So the chickens were going through all of our food waste. We also had restaurant rescue that was going through animals. We had rabbits for breaking down a lot of like the prunings and like kind of heavier greens, which were also, so we also got like chicken and rabbit manure. So all of those things were kind of counted as composting systems. We never actually had a compost pile. And for a lot of people, I don't actually recommend them. I think there's a lot more creative ways that you can get that composting to happen. Try to come up with a few different methods that you can use that are relevant for your site. Any materials needed, anything that you actually need that you already have on site, you can highlight in orange, and then just give you a basic timeline of when those things are going to happen. So, okay, and then you can detail a little bit about how your soil building plan is going to respond to the limiting factors that you've noticed in your soil. So you've got a heavy soil, how you can work on getting lighter organic material incorporated. You've got often the answer is just add more organic material. So for a soil that's really rich in clay or is really light and friable, often adding organic material is a good way of doing that. But you might want to add more manures, less. So for a clay soil, I tend towards more like wood chip material because often the nutrients are there. They're just bound up in clay. Whereas with a sandy soil, I tend towards more manures, kind of a less of a wood chip because there's going to be less nutrients bound up in a soil, in a sandy soil than there would be in, say, a clay-rich soil. And then just, do you have the materials that you need to adapt that, or are those going to be things that you're going to need to bring in? We've got a SWOT analysis, which you're all doing great with and should be familiar by now. Your goals based on the assignment, what you learned through this assignment, and then any questions and feedback. And that's it. That's your soil mapping assignment. So it's a fairly nice kind of cohesive one. It doesn't, I think it's one of the shorter, maybe more straightforward assignments in the course. So, and I tend to, it seems like students generally get, there's a good return on investment for this one. Like it feels really good to actually get physically into your site and get your hands in there and be like, okay, we're actually working with the site. Yes. Like we're actually working with the site now instead of just doing all this computer stuff. So.
Yeah, absolutely.
Okay.
It's great.
And Vincent, you said you've done your soil tests already, or have you just selected your sites?
I picked the sites and I put the soil in jars and I forgot to put the soap. So I think I may have to redo it because the soil is pretty uniform almost throughout the jar. And so I need to take some sample and add the soap or something. Because I'm not getting the layers like it showed in the video for some reason. So I'm guessing it's probably the soap. But we also have very shallow soil. So we're like 27 inches to bed.
Gotcha. Okay.
And it's all clay. So
Yeah.
it,
Yeah.
it's yeah. I can't tell if it's that or that I just did it wrong. So I'm going to try it again and see what
Yeah.
happens.
And you're Penn Valley, correct?
Yeah. Yeah.
Yeah. Okay. One thing that you may want to do a little bit of reading into is dispersive clays. So dispersive versus non-dispersive clays, because the West Coast, I mean, really, I don't know how much it extends up into Oregon and Washington, and I'm familiar with it from being in California, but there are kind of like ribbons. It's this very heterogeneous, like patchwork of dispersive soils, which is where the clay has a certain magnesium calcium ratio that when they get saturated, instead of just getting like wet and sticky, they kind of explode. So it's actually kind of a leading cause of a lot of these like massive mudslides and like tunneling. Like when it gets saturated, basically the soil just loses all of its structure and blows out instead of just becoming like gluey and sticky like clays that with different nutrient ratios. So you might want to do a little bit of reading in that. And there's some good materials on like dispersive clays that are worth knowing about if it's for your site, because it can really impact, like if you're planning swales or any kind of ponding and stuff, you want to make sure to plan for that. Just because you're in that area, and I know when I've looked into it, like there's some kind of streams that come down the coast. Maybe seams is a better word for like geological features, but I know further inland towards the Sierras, you get like bigger, more homogeneous patches of those kind of clays. So
Yeah, I'll have to look at that. Yeah, the soil here is real shallow. I found just even trying to dig the hole to get the native soil, it was pulling out rocks almost the size of my hand,
Oh,
just
wow.
to get down to actually pull out enough soil to test.
Yeah.
So I know the soil's very thin. When I'm down the road, when I'm looking to amend that, is the best practice just to put the organic matter on top and let it just over time naturally sink in, or should I actually like try to almost trench it and fold it in like I was trying to bake, or what other methods do you think?
Yeah, my inclination, I mean, knowing a little bit of that area, my inclination would be just put stuff on top, just like lasagna garden it, basically. Now, for me, lasagna gardening was always like if you've got a quarter of an acre, or a backyard garden, it's a good strategy. But beyond that, it doesn't mean much. But this property that we're living on now, actually, the landlady who lives on site is from New Mexico, and she used to run a farm operation where they would do like 16 acres of lasagna gardening. So they would get in truckloads of compost, truckloads of cardboard, truckloads and they would just get teams of people that would like lay these things out. So the research on like compost application, I don't know if you're familiar with the I wish I could remember more than pieces of information cohesively. But the Marin Compost Project, or I think it's Marin Soil Compost or Marin Carbon Project. And the researcher's first name is Wendy, and I can't remember. Basically, the long and the short of it is that they found that even a half inch layer of compost over large areas was enough to significantly boost like the carbon capture potential and soil health. So it's not like you need to be dumping, dump truckloads of compost on top of soils in order to get that biology kick-started. Like it really doesn't need to be very much. So I would definitely tend to just kind of layer things on top and, let it kind of work itself out over time.
Got it.
Jeff? Wendy Silver. There we go. So she was the lead scientist on that project. I'm just going to drop a link in the. There you go. Link in the chat there.
Oh, okay.
What was that, Karen?
Oh, no, so I also did the same thing. I went and looked it up.
Oh, yeah. Okay. Yeah. Well, I was like, I should know this. The advisor that I was planning to work with on my for my PhD, like years and years ago, before I anyway, was one of her grad students. So we heard a lot about the Marine Carbon Project.
All right.
But, yeah. Okay.
In the case that I do have like the dispersive clay, because I'm starting to look into it, and just based on the region, it looks like it's really common for this area. So if that is the case, does that remove options like swales from play because of the fact that blowouts could happen, or does it just reduce the size that I would be allowed, or that I should consider building them in?
Probably both, and it would be a case where I wouldn't really venture down that road without a geotechnical, like an engineer, like someone certified in basically certifying that whatever I'm doing is going to be safe. No, I can't recall. I don't have the link to your project up. I'm trying. Are you on a fairly steep slope?
But I think the steepest parts are maybe like 30%, something like that for the
Okay.
steepest portions. So it can be significant in some areas. The primary place of the project is less steep though. If
You're about 5 acres. Yeah. Okay.
Yeah, I think the slide that looks at it best. Actually, the one that we did for the water survey, slide 60,
Yeah.
kind of shows.
Okay. I'm just trying to share here. There we go. So,
we're looking at slide 60. It shows like the contour lines pretty well, and I drew the arrow, quite a few arrows. I went a little crazy on the arrows.
Oh, you did. Okay, so you're at the top of the hill. You're on the ridge then.
Yeah, the house is pretty much right on the ridge, and where I'm looking to build, or well, that's going to be the main project area, is if you look just beyond the divide towards the bottom portion where that flat area is, the green purple line split there, yeah. So towards the south, or well, southwest from there. So just along that the valley that goes through there. That's pretty much where I'm looking to expand. There's a little vineyard there right now, and so around that, I want to basically turn into a bit of a probably like an orchard or something like that, a food forest if possible. But given that's where the water kind of is naturally flowing through, and then slow it down as it passes through that space is the idea. But as you can see, like the contour lines are the widest there. So I was hoping that we might be able to pull it off in that space, but the rest of the property is pretty steep.
Yeah. Okay. So it's fairly level there, but it's also a fairly small area. So you've got, you're kind of on the rooftop, right? So
I think it might be better if I just drew a box. I just realized we're in Google. I can do that.
Oh,
so
I see. Okay.
That space is where I'm looking at doing the food forest stuff.
Oh, gotcha. Okay, I see what you mean. Yeah, that makes more sense. Like, this doesn't. Okay. So just below the rooftop then.
Yeah, that area where you were hovering is the vegetable garden now, and so we have a veggie garden there. And then downhill from that is where we want to start the food forest setup.
Mm-hmm. Mm-hmm. Okay. Where's the boundary? Okay. Yeah, it's just something that I would at least have someone, make friends with someone or like come out and walk the site, or, find out what they would charge you for a couple hours of their time, to make sure if you were going to be doing any earthworks in there. And besides the fact that if there's a lot of rocks in there, it's going to be more unstable. And, you might very well be creating pockets and stuff. It would be really hard to get, like that nice level swale that you actually need in order to do that kind of water capture. But I can see why you've chosen that spot. So what?
I was kind of looking at like 3 different options for trying to infiltrate water. One was, swales, which I think are too risky because there's too much water that they capture. 2 was doing some sort of like hugel mound kind of swale where hopefully the wood would soak up some of the water. But then I was worried that because bedrock is so shallow, like it could float off the log and then blow it out and have the same problem. And then 3 was like the kind of the half moon type swales. I saw Andrew doing, and or he was doing. I saw one of Andrew's videos in the greening the not greening the desert, the green wall, the Great Green Wall in Africa, where they were doing the half moons. But I think that was a lot more flat ground, so I think it would still be prone to the same kind of blowout. But again, I don't know anything.
Well, I think in your case, no, like with that terrain, I think probably the hugel-like constructions is probably your best bet, because you don't get like monsoon rains typically, correct?
Not too much. Last year we got quite a bit though. We got quite a bit of rain for like 3 months. It just rained almost every day. Like it was crazy.
Okay. So that's something, it seems like something you could do kind of like, and especially if you kind of nestled that into like, kind of built it into the existing terrain or rock work, so you got more infiltration without creating any big structures that are likely to blow out. But yeah, that sounds like something I'd want to get someone on the ground doing some testing and finding out, because the other thing is that with your heavy tree cover, your contour map is going to be skewed by the fact that you've got some pretty dense tree cover, like especially towards the bottom. So it's, you'd really want to ground truth the contour map before you did too much planning in there, because that, that dense tree cover can definitely throw off contour lines. So,
and one more question on that too, like up in this area here, we have a lot of terraces that were pre-built when we moved into the property.
okay.
Are in this kind of environment, do terraces hold the same kind of risks as like swales would, for example, or are they a bit safer from like blowout scenarios?
That's a good question. I don't know, because I've seen a lot of like retaining walls fail, but how high are the terraces?
I think the tallest one is maybe 3 feet, maybe.
Yeah.
It's 2.5 feet, probably close to 3.
Yeah, so I mean, terraces can be a good way to go, because you're not collecting so much water and you're actually planting into them. That's an interesting question. Because we've all seen retaining walls blow out, which is basically a terrace. Now, terrace, you'd want to tip back a little bit into the hillside so that you get more water capture. The one issue that we had significant problems with terraces was gophers, tunneling through from the top down to the bottom, down to the lower terraces. So basically, it was actually like the wildlife creating instability because the soil in those terraces was lighter and fluffier, and they could dig through it more, and so it tended to fail. But they would basically, then the water would just leak out through the bottom. So
the other idea I had was to take like a hugel mound basically, and then cover it on the downhill side with like a 2-foot retaining wall or terrace, basically, to hold it all kind of in place.
Yeah.
And then hopefully things worked out. But again, I don't know if that even makes sense or would be safe.
Yeah. Well, I mean, to me, that would make a lot of sense in being in a fairly conservative way to go, especially if you started at like a foot or two and then sort of built it up over time. Rather than, because something like a swale is really like, it's more of an excavation thing, whereas with terraces, you can build it onto the existing landscape. And it sort of becomes more like a leaky weir, like where you've got water set to percolate through a little bit if there's a large amount. So I mean, if it were me, I would tend towards terraces rather than really like water holding swales or conservation ditches. But again, go ahead.
Kind of start the terraces with like because we have so many large rocks. I was actually thinking about starting the terraces just a long check dam, and just see how the water flows through the check dam, and then add layer upon layer as I figure that out. Is that a smart way to do that, or is that just kind of a waste of time?
No, I know. I think, and I have seen that work, like sort of one rock dams built up, like especially coming up into like a valley, like into a V-shaped catchment, and you just basically build up behind one another. And then if one further up fails, then it just kind of drops into the next one. Now there's overlap in function here, right? I mean, like, when we're thinking of a swale, it's often something that's been dug into, it's more of an earthworks and being kind of like dug into the landscape. But really, it's just any kind of thing that's going to like slow and capture and hold some water. And it's, on contours with level. So it's not draining one like sideways, laterally one way or the other. So, I mean, you're basically, when you're talking about terraces, what I'm envisioning is kind of something that's somewhere in between. It's just basically a level terrace that's really, I mean, it's functioning in a way as a swale, but you've got like a rock, some sort of like a solid feature in front of it instead of a permeable berm. Right?
Seems to me if you've got rocks, you should use them.
Yeah.
Yeah. We have those in abundance. I think I have more rock than soil, to be honest.
Yeah. You really do have a lot, though.
Do you have something? Does vetiver grass grow where you are, or something like that really has a tough, tight root system that stops water?
I honestly don't know.
Stop water.
So
Probably.
There was a vetiver grass nursery in, I want to say Carpinteria, so just south of Santa Barbara. Now, we tried contacting them a number of times. Grassland Growers. Retention basins. You might want to reach out to them. That's a really good suggestion, Karen.
Because if you have rocks and vetiver grass, you kind of have a way of building up the soil behind it, especially if you're plant trees. Is your soil deep enough to plant a fruit tree? What kind of fruit trees are you growing?
Yeah, so today we have several citrus trees that are in the native soil, kind of in this, where is it at? Uh-oh, I did something. Hold on. Technology. So over in this space, I can't. Can I twist it?
Can you? There should be a
like
rotation. Yeah, okay.
There we go. So in that space, we have an orchard today with about 30 fruit trees in it. So there's citrus. Okay. We have a few pears, plums,
Oh, wow.
that kind of stuff, figs in that space. And then throughout
Okay.
the property, we have a couple other orange trees and fig trees and stuff like that.
Okay.
But they're in pretty well-prepared areas, is what I'll say. So one is like right outside the garden, one's in the front lawn, another is like they were intentionally placed. And so I'm sure there was a lot of work that went into getting them to take off in those spaces, where the soil out in the orchard is more native, but it also seems thicker in that space from the couple of times I've tried to dig in it. It's a little bit further to the bedrock than it is in some of the other areas around the property.
So, Vincent, this house is on another property, correct? Like this is your.
Yeah, the bottom part is a different property. It's just if you look at the map on slide 59, you'll see the contour lines. That's pretty much the watershed. That's it. That's all we get.
Yeah, no, and that made a lot of sense to include that because it's so clearly draining onto your property. So that's fine. I just wanted to double check that was what I was seeing. Okay. Okay, we're at time. Now, do you want to keep going on this for a little bit, Vincent? I just wanted to make sure that you got questions answered.
Oh, I could talk about this all day. I love this. This lesson's been great.
Okay.
It's really kind of got me thinking about what to do with the property, and specifically that main project area, because it's just, I know how dangerous it can be with the mudslides and blowouts and things like that, just from trying to hold water inappropriately. And so trying to plan it out so that it's not a hazard to us or anybody downhill from us is really the goal right now. So.
Have you guys had significant mudslides around you?
No. I honestly don't know that, because we're so high up on the ridgeline. I don't think there's enough force to come down, or enough water to be captured in the soil for it to roll down. It all just runs off fairly quickly because of the slope. So it doesn't really infiltrate, and even if it did, there's not a whole lot of space for it to infiltrate to, because of how shallow it is.
Right.
So it's just over time, if I'm building it up, then I start getting concerned.
Mm-hmm. Yeah. Well, and when we look at these big mudslides that we've had, I mean, it's in these areas with gigantic roof surfaces and so much concretization that it's really just channeling like so much water into a small area. And that's where there's these huge blowouts and mudslides are happening, not so much where you've got like one little property and you're capturing a little bit of water here and there. So, I mean, I always want to proceed with caution, but I mean, you also, your site pretty well, and you've clearly got plenty of common sense to work with. So I think, kind of starting small, how things behave, like, I think you're fine. So,
cool. Thank you.
Yeah. Okay. All right. Well, it's nice to see you both again.
Yeah. Thanks very much.
Okay.
Appreciate it.
All right.
Okay.
You guys have a good week. And shoot me any questions by email if you need.
Thank you very much.
Okay.
Thank you.
Okay.
Bye.
Bye.